Real mode, also called real address mode, is an operating mode of all x86 compatible CPUs. Real mode is characterized by a 20-bit segmented memory address space and unlimited direct software access to all addressable memory, I/O addresses and peripheral hardware. Real mode provides no support for memory protection, multitasking, or code privilege levels. Before the release of the 80286, which introduced protected mode, real mode was the only available mode for x86 CPUs. In the interests of backwards compatibility, all x86 CPUs start in real mode when reset, though it is possible to emulate real mode on other systems when starting on other modes. History: the 286 architecture introduced protected mode, allowing for hardware-level memory protection. Using these new features, however, required a new operating system that was specifically designed for protected mode. Since a primary design specification of x86 microprocessors is that they are fully backwards compatible with software written for all x86 chips before them, the 286 chip was made to start in real mode that is, in a mode which turn off the new memory protection features, so that it could run operating systems written for the 8086 and the 80186. As of 2014, even the newest x86 CPUs start in real mode at power on and can run software written for almost any previous x86 chip. The PC BIOS which IBM introduced operates in real mode, as do the DOS operating systems. Early versions of Microsoft Windows ran in real mode. Windows 386 made it possible to make some use of protected mode, and this was more fully realized in Windows 3.0, which could run in either real mode or make use of protected mode in the manner of Windows 386. Windows 3.0 actually had several modes: real mode, standard mode, and 386 enhanced mode. The latter required some of the virtualization features of the 80386 processor, and thus would not run on an 80286. Windows 3.1 removed support for real mode, and it was the first mainstream operating environment which required at least an 80286 processor. Windows 95 architecture is an evolution of Windows for Workgroups 386 enhanced mode. None of these versions could be considered a modern x86 operating system, since they switched to protected mode only for certain functions. Are considered modern OSs as they switch the CPU into protected mode at startup, never return to real mode and provide all of the benefits of protected mode all of the time. 64-bit operating systems use this only as another stepping stone to get to long mode. It is worth noting that the protected mode of the 80286 is considerably more primitive than the improved protected mode introduced with the 80386. The latter is sometimes called 386 protected mode, and is the mode modern 32-bit x86 operating systems run in. Addressing capacity: the 8086, 8088, and 80186 have a 20-bit address bus, but the unusual segmented addressing scheme Intel chose for these processors actually produces effective addresses which can have 21 significant bits. This scheme shifts a 16-bit segment number left 4 bits before adding to it a 16-bit address offset. The maximum sum occurs when both the segment and offset are 0xFFFF, yielding 0xFFFFO plus 0xFFFF equals 0x10FFEF. On the 8086, 8088, and 80186, the result of an effective address that overflows 20 bits is that the address wraps around to the zero end of the address range, that is, it is taken modulo 220. However, the 80286 has 24 address bits and computes effective addresses to 24 bits even in real mode. Therefore, for the segment 0xFFFF and offset greater than 0x100F, the 80286 would actually make an access into the beginning of the second megabyte of memory, whereas the 80186 and earlier would access an address equal to offset minus 0 times 10, which is at the beginning of the first megabyte. So, The actual amount of memory addressable by the 80,286 and later x86 CPUs in real mode is 1 MB plus 64 KB Euro 16 bytes equals 1,114,096 B. A20 Line. Some programs predating the 80,286 were designed to take advantage of the wraparound memory addressing behavior, so the 80,286 presented a problem for backward compatibility. Forcing the 21st address line to a logic low, representing a 0, results in a modulo 220 effect to match the earlier processor's address arithmetic, but the 80,286 has no internal capability to perform this function. When IBM used the 80,286 in their IBM Personal Computer AT, they solved this problem by including a software-settable gate to enable or disable the A20 address line, between the A20 pin on the 80,286 and the system bus. This is known as gate A20, and it is still implemented in PC chipsets to this day. Most versions of the HIMMS's extended memory driver for IBM/MS-DOS famously displayed upon loading a message that they had installed an A20 handler, a piece of software to control gate A20 and coordinate it to the needs of programs. In protected mode, the A20 line needs to be enabled, or else physical addressing errors will occur, likely leading to a system crash. Switching to real mode. Intel introduced protected mode into the x86 family with the intention that operating systems which used it would run entirely in the new mode and that all programs running under a protected mode operating system would run in protected mode as well. Because of the substantial differences between real mode and even the rather limited 286 protected mode, programs written for real mode cannot run in protected mode without being rewritten. Therefore, with a wide base of existing real mode applications which users depended on, abandoning real mode posed problems for the industry, and programmers sought a way to switch between the modes at will. However, Intel, consistent with their intentions for the processor's usage, provided an easy way to switch into protected mode on the 80,286 but no easy way to switch back to real mode. Before the 386, the only way to switch from protected mode back to real mode was to reset the processor. After a reset, it always starts up in real mode to be compatible with earlier x86 CPUs back to the 8086. Resetting the processor does not clear the system's RAM, so this, while awkward and inefficient, is actually feasible. From protected mode, the processor's state is saved in memory, then the processor is reset, restarts in real mode, and executes some real mode code to restore the saved state from memory. It can then run other real mode code until the program is ready to switch back to protected mode. The switch to real mode is costly in terms of time, but this technique allows protected mode programs to use services such as BIOS, which runs entirely in real mode 5150. This mode switching technique is also the one used by DPMI and DOS extenders like DOS/4GW to allow protected mode programs to run under DOS. The DPMI system or DOS extender switches to real mode to invoke DOS or BIOS calls, then switches back to return to the application program which runs in protected mode. Decline. The changing towards the NT kernel resulted in the operating system not needing DOS to boot the computer as well as unable to use it. The need to restart the computer in real mode as DOS declined after Windows 3.1x until it was no longer needed. The only way of currently running DOS applications in real mode from within newer versions of Windows is by using emulators such as DOSBox or x86 virtualization products. See also, Unreal Mode. 80,386, IA32, x86 assembly language, conventional memory. References. External links, The Real, Protected, Long Mode Assembly Tutorial for PCs.